Hello everyone. Today we're going to explore serverless computing, specifically AWS Lambda. In this video session, we'll dive into AWS Lambda, explore its key features and practical use cases. Towards the end, we will conclude with a hands-on demo to solidify your understanding. AWS Lambda is a service offered by Amazon Web Services that lets you run code without managing servers. It triggers your code in response to events like a user uploading a file and automatically scales to handle the workload. This serverless approach allows you to focus on writing code without infrastructure headaches, making it cost-effective for tasks that require variable compute power. Features of Lambda include running code without provisioning or managing infrastructure by simply writing and uploading code as a zip file or container image. Lambda comes with native support for a number of programming languages: Java, Go, PowerShell, Node.js, C#, Python, and Ruby code, and provides a runtime API which allows you to use any additional programming languages to author your functions. As your Lambda function receives more requests, Lambda automatically provisions additional execution environments to handle them concurrently. This ensures smooth operation even during traffic spikes. AWS Lambda allows you to add custom logic to AWS resources such as Amazon S3 buckets and Amazon DynamoDB tables, so you can easily apply changes to data as it enters or moves through the cloud. Unlike traditional server deployments where you pay for infrastructure even during idle periods, Lambda operates on a pay-per-use billing model. You're charged based on two key factors. Compute time. The amount of time your function takes to execute is measured in milliseconds. You are billed based on total compute time used across all your functions per month. Request invocations. Each time your Lambda function executes in response to an event, like an API gateway request or S3 upload, counts as a request. You are billed based on the number of requests processed per month. AWS Lambda integrates with other AWS services to provide built-in monitoring for your Lambda functions to help you monitor and troubleshoot. Lambda automatically monitors functions on your behalf and reports logs to Amazon CloudWatch logs. Some use cases of AWS Lambda are: Lambda can be triggered by file uploads to S3 buckets, allowing you to automatically transform and process data files. This is useful for tasks like image resizing, PDF conversion, and data validation. Using Lambda scheduled events is a great way of performing housekeeping within your account. By using AWS Lambda, you can create backups, check for idle resources, generate reports, and perform other common tasks quickly. Any organization that engages in marketing has mass mailing services as part of its marketing services. You can build a serverless email platform using AWS Lambda and simple email service quite easily, which can scale in line with your application. Many organizations use Lambda to build serverless API backends using Amazon API Gateway. This approach provides a scalable and cost-effective solution for handling API requests. Lambda functions can validate and enrich incoming data, ensuring that only clean and enriched data enters your database or data warehouses. In this demo, we will showcase an automated CSV to JSON file conversion process, automated with the help of AWS Lambda. When a CSV file is uploaded to the source S3 bucket, an event triggers a Lambda function to process the file. This function transforms the CSV data into a JSON and stores the resulting file in the designated target S3 bucket. So, let's have a look at our demo. First, we'll start by navigating to Amazon S3. Click on Create Bucket and name the first bucket Thinknyx Files. This will be our source bucket, where we'll upload CSV files. Leave the other options as they are and proceed by clicking the Create Bucket button. Repeat these steps to create another bucket named Thinknyx Files Target, which will serve as our target bucket. With our bucket set up, let's move to AWS Lambda. Click on Create Function and name it My Lambda Function. Choose Python as the runtime. In the permissions section, click on the IAM console link to create a role for the Lambda function. Select Lambda as the service link. Click Next. Search for S3 in the search bar and choose Amazon S3 Full Access. Name the role My Lambda function and create it. Close this tab, select the newly created role and click Create Function. Now, in the code section, paste the provided Python code from the description and click Deploy. Scroll up and click Add Trigger. Select S3 and choose the Thinknyx files bucket. Keep the event type unchanged and click Add Trigger. Our Lambda function is now set up. To see it in action, go to the Thinknyx files S3 bucket, upload a CSV file, and then head over to the Thinknyx files target bucket. After a short wait, click the refresh button. You'll now see a JSON file uploaded to the target bucket. Thank you for watching. Don't forget to like, share, and subscribe for more tech insights. I'll see you in the next video.
Thinknyx. You trust, we deliver.